All right, so today, since we answered all the questions that were in about last night's homework, the pile has returned to the desk. At some point in time before you leave today, make sure you turn in your homework over on the desk. What I'd like you to do right now is I kind of want you to go back thinking about your prior math classes, because we've solved by substitution before, okay, in Algebra 1 and Algebra 2, some in geometry, okay, and I want you to try and solve this system of equations using substitution, okay, so go for it. There we go, now we're ready to go. All right, so, anybody get an answer? What do you got? -1? Just -1? Okay. All right. And anybody get an answer? Because remember, our three choices for answers are a point, so an x comma y, no solution or infinite solutions. Okay. Okay. All right. All right. So we got to do a little remembering of memory. Trying to come up with different re's there, okay? So, let's come up with a strategery to do substitution, okay? So, the first step in substitution is going to be, you are going to solve one of the equations for one of the variables, okay? Doesn't matter which one, doesn't matter which equation it comes from. Okay, but you need to solve one of the two equations for one of the two variables. Okay? Now, I like to not work very hard. I like to be smart in my work so I don't have to work hard. If I got to work hard, I'll work hard. But if I can make it, go easier for me in terms of my work, I do that. So if we go back here to this one of the four variables, or spots, is an easy solve. Color and letter. Which one do you think is the easiest one to solve? Color and letter. Blue or red, X or Y. Which one do you think would be the easiest variable to solve for? Blue. Blue X or blue Y? Blue Y, right? Because it's all by itself already. Right? So, you have the choice. You could solve for red X, you could solve for red Y, you could solve for blue X, you could solve for blue Y. Make it easy on yourself. Solve for blue Y. Okay? Sometimes, it's going to be like the seas are parting and you go, whoa! Make it that simple. Okay? Don't make it any harder on yourself. So we're going to solve this first equation by adding 2x to both sides for y. Now, if you wrote it as y equals 2x plus 4, great. If you wrote it as y equals 4 plus 2x, you're at the same spot. Okay? There's no difference in 2x plus 4 and 4 plus 2x. Okay? It's more a matter of personal preference. Okay? So, we did step 1. We solved one of the equations for one of the variables. Step 2 says we are going to substitute that now into our other equation for that particular variable that we solved for. So we solved the blue equation for y. So we're going to take what y is equal to, 2x plus 4, and we're going to substitute it in the red equation in y's place. Give you a couple of seconds to get that written down. Okay, so back here, in action, I'm going to take 2x plus 4, because that's what's equal to y, and I'm going to put it in place of y. So this now becomes 3x plus 2 times 2x plus 4 equals 1. I replaced y with 2x plus 4. Substituted, if you will. Step number 3. Now that we've got an equation with one variable in it, we can solve it. So I'm going to solve my new equation. I'm going to solve that, in this case, for x. Oops, wrong way. This way. Okay? So I'm going to solve this red equation. First off, I'm going to distribute. So that gives me 3x plus 4x plus 8 equals 1. That's 7x plus 8 equals 1. That's 7x equals negative 7 when I subtract 8 from both sides. Divide by 7, that's x equals negative 1. So you were on the right track, just you stopped at step 3. Right? Now, what we're going to do that we've solved is we are now going to take that, what we just solved for, and we're going to put it back into the first equation that we had, and we're going to get the other variable. Okay? So what that means here, I got to scroll down here a little bit. What that means here now is I am going to take negative 1 and I am going to put it back into that blue equation and solve for y. So this becomes y equals 2 times negative 1 plus 4. 2 times negative 1 is negative 2, plus 4 is positive 2. Lastly, what we're going to do is we are going to plug our solutions, okay, or our solution, back into both of our original equations to check if we are correct. We should know at the end of the problem if we are right or not, because we have done step 5 where we checked our answer. And then our final answer is going to be in point form. Okay? So we need to check it back in the original equations and then put our answer in point form. So if I check this, negative 1 times 3 is negative 3. 2 times 2 is 4. Negative 3 plus 4 is 1. So my answer, my x answer, my y answer check out in my red equation. Negative 2 times negative 1 is positive 2. 2 plus 2 is 4. Checks out in my blue equation. So therefore, I can write my answer now in point form as negative 1, comma 2. Okay. Step 1, solve one of the equations for one of the variables. Step 2, put it in the other equation in place of. Step 3, solve. Step 4, put it back in the other equation. Step 5, check. Okay. What I'd like you to do now is I'd like you to apply those 5 steps for substitution on this system of equations. Step number 1, I would probably solve my second equation for x, giving me x equals negative 5y minus 9. Then I'm going to take that in step number 2, and I am going to put that in for x, giving me 4 times negative 5y minus 9 plus 3y equals negative 2. In this case, I'm going to solve for y. So, distribute here gives me negative 20y minus 36 plus 3y equals negative 2. Negative 17y equals positive 34. Y equals negative 2. Taking that then and putting it back in for y up there gives me x equals negative 5 times negative 2 minus 9. Negative 5 times negative 2 is positive 10. 10 minus 9 is positive 1. Checking both of those answers, 4 times 1 is 1. Excuse me, 4 times 1 is 4. 3 times negative 2 is negative 6. 4 plus negative 6 is negative 2. Checks out in the left one. 1 is 1. 5 times negative 2 is negative 10. 1 plus negative 10 is negative 9. Checks out in the other one. So I know before I even go on to the next problem that, oh yeah, we is right. You're going the wrong way.
Brought bronze first.
Yep. Questions on that one? Sometimes in life, you get some fractions. Okay? Try it. Robbie, you said you don't do fractions, right?
I'm doing it right now.
Well, no, but I'm saying you don't do them, right?
Well, I did them this year because it's what this class is.
It's all about fractions, right?
Exactly.
Okay. But so if you don't like fractions, and a lot of people don't like fractions, what option do you have?
Decimals.
What?
You can convert it to decimals.
But see, I don't like decimals because 2/3 is not a nice decimal. It's a repeating decimal. So we can't just convert them to decimals. So what other option do we have? Get rid of the fraction. So how would I get rid of the fraction in the first one? In 2/3 x plus 3y equals negative 34. How would I get rid of that fraction? Multiply both sides by 3. So basically what you're saying here is we're going to take the entire equation here and we're going to multiply every term by 3. If I do that, multiply every term by 3, I get 2x plus 9y equals negative 102. Same equation without fractions. Yeah. What would I multiply the second equation by? If I multiply by 2, I get x minus 1/2 y equals negative 1. And I still have a fraction. So what's the common denominator between 2 and 4? 4. So we'd multiply both sides by 4. That gives me 2x minus y equals negative 2. Same equation, just written without fractions. Okay. So now that you've gotten rid of your fractions, you've dealt with them, you've dealt with your fractions, now we can do substitution. Okay? Go from there. So I would probably solve red for y. And that gives me y, oops, excuse me, tap the brakes. That gives me 2x plus 2 is equal to y. Okay. Then this, oops, went to the wrong spot again. Come on, man. Goes in there. That gives me 2x plus 9 times 2x plus 2 equals negative 102. Distribute 2x plus 18x plus 18 equals negative 102. 20x equals negative 120. X equals negative 6. Take that. Put it in there. Gives me 2 times negative 6 plus 2 is y. 2 times negative 6 is negative 12. Plus 2 is negative 10. So negative 10 is equal to y. Okay. Quick check. 2/3, because we go back to our original equation, 2/3 times negative 6 plus 3 times negative 10 has to equal negative 34. 2/3 times negative 6 is negative 4. 3 times negative 10 is negative 30. Those two add together to be negative 34. So it works out there. 1/2 times negative 6 plus, minus 1/4 times negative 10 has to equal negative 1/2. 1/2 times negative 6 is negative 3. 1/4 times negative 10 is negative 10/4, which is negative 5/2. So in my brain, I'm thinking of 3, but I'm not thinking of it as 3. I'm thinking of it as negative 6/2 plus 5/2. Negative 6/2 plus 5/2 is negative 1/2. So it does check out. So my answer here is negative 6, comma, negative 10. Okay. Yes, ma'am.
So if it doesn't come out right, that just means that you did the math wrong?
You did something wrong. Yep. And so that's why we always go back to the original equations to check our answers. Because if something happened, if we didn't get true answers, truthiness down here in our check, something happened between here and our original equations that we did wrong. Okay? If I go to the, like in this fraction one, if I would go back to my original blue and my original red equations to check them, something might have happened in between there, before there, that we did wrong and that I didn't pick up on. So that's why we don't go back and check anywhere but in our original equations. Okay? All right. Two special situations that we need to deal with here, because, as we said earlier, we can have an answer be a point, which the last 3 examples have all been an answer of a point, or we could have no solution, or we could have infinite solutions. So those last two, no solution, infinite solution, create two special situations. Okay? So, on this first one, situation number 1, actually we'll do this. Let's shade it up here. Okay? Got to put some color in our lives. There we go. Okay? Gold standard. That's what we are, David. The gold standard. Okay? So, looking at these two equations, any variable pop out to you that would make it easy to solve for? Anyone? Top x, bottom x, top y, bottom y. All look kind of ugly, right? Okay. So it really doesn't matter which one we're going to solve for. So let's solve the top equation for x. If I solve this top equation for x, I'm going to get 3x equals 6y plus 14, which is going to give me x, because I'm going to have to divide here now by 3. So I'm going to get x equals, sure I will, I'm going to get x equals 6y plus 14 all over 3. And I can leave it like that. I could also write it as 2y plus 14 thirds. Okay? But I can just leave it like that because I'm substituting that into my other equation. So this is going to go there. So that gives me negative 6 times 6y plus 14 all over 3 plus 12y equals negative 16. Distributing in, this 3 goes into this 6 negative 2 times. Okay. So really I have to distribute in a negative 2 into those two spots. So that gives me negative 12y 12y minus 28 plus 12y equals negative 16. If I simplify the left side, negative 12y plus 12y is 0, minus 28 is negative 28 equals negative 16. What's wrong with negative 28 equals negative 16? What's wrong with that statement? First off, they're not equal, so it's a false statement. And second, we're solving. What are we solving for?
Variable.
Do we have one though? No. So we've lost our variables and we've got a false statement. So when you lose your variables, here's the downfall with the shade. I gotta get rid of the shade now so I can extend my page. Okay? So we've got a false statement with no variables.
Is there a worksheet for that one?
Nope, out of the book. Okay. So we got a false statement with no variables. Okay? Now, saying if we had something along the lines of y equals 0 here, that is not a false statement with no variables. That just means that y is 0. 0 is a number, we can get that. Okay? All right? So when we have a false statement with no variables, that is going to be a no solution case.
And this can be like any equation with numbers, or is it just these specific ones?
Like these.
Yeah, like it can be anyone.
Yeah,
Like,
so when you're going through in the substitution process,
yeah.
so if I go back here a slide, if we would have gotten here, and I would have gotten something like, if these two would have canceled out right there, okay? So if those two cancel out, and I got 18 equals negative 102, that's a no solution case, okay? It doesn't matter what the equations are, it's just if the variables cancel out, and it would be in that after you substituted step. Okay? All right? That's a no solutions case. Situation number 2. Again, not a very pretty one to solve for, so we'll solve this top one for x. Again, gives me, bless you, gives me 4y plus 13 all over 2. Then that is going in for x. So then that becomes this one, negative 2 times plus 4y equals negative 13. And that inside is going to be 4y plus 13 all over 2. That looks like a B. Let's fix that. Much better. Okay. So this 2 cancels out that 2. So the only thing that I have to distribute in here is the negative sign. When I distribute in the negative sign, I get negative 4y minus 13 plus 4y equals negative 13. Or simply put, negative 13 equals negative 13, or 0 equals 0. Okay. That is a true statement with no variables. And so that is the infinite solutions case. Okay. So again, if you have variables that cancel out, and it results in a true sentence, infinite solutions. Variables that cancel out, resulting in a false sentence, no solutions. If your variables don't cancel, you will get a point. Okay, now that point might not be pretty. You might have fractional answers. Okay? And remember, we like fractional answers as opposed to decimal answers. Okay? Alright. Homework this evening. Remember, all homework is due at the next class, so this will be due on Monday. Okay. It's a grand total of 6 problems. Okay. So, page 164 to 165, 7 through 13 odds, 7, 9, 11, and 13, and then 47 and 55. I want to say that 47 and 55, one is a fraction problem, one is a word problem. Woo!